Welcome to Simultaneous Equations Level 3. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 3a plus 8b equals 31 and 5a plus 3b equals 31. Now to solve these equations, we need to eliminate one of the variables, and to do this we need to have the same number in front of each pair of variables in the two equations. At the moment we don't. So what we could do here is multiply the top equation by 5 and the bottom equation by 3, and this would give us 15a in both equations. Alternatively, we could multiply the top equation by 3 and the bottom equation by 8, and this will give us 24b's in both equations. Since it uses slightly smaller numbers, I'm going to go with the first option, which is multiplying the first equation by 5 and the second equation by 3 to make the number in front of the a's the same in each. So starting with the first equation, 3a times 5 is 15a, 8b times 5 is plus 40b, and 31 times 5 gives us 155. In the second equation, 5a times 3 is 15a, 3b times 3 is plus 9b, and 31 times 3 is 93. Now here we're going to be eliminating the a's, and since we have the same sign in front of both because they're both positive, we're going to subtract them, because 15a minus 15a gives us 0. So subtracting the bottom equation from the top, we have 15a minus 15a, which is 0, 40b minus 9b gives us 31b, and 155 minus 93 gives us 62. We can now find b by solving this equation, and we can do this by removing the times 31 from in front of the b, and we do this by dividing by 31 and doing the same on the right. And on the left, the times 31 and the divide by 31 cancel out to leave us with b, and on the right, 62 divided by 31 is 2. So b equals 2 is the first part of our solution. To find the value of a, we can now substitute this value of b back into one of the original two equations, and they're very similar, so it doesn't really make a huge amount of difference which one I use, but I'm just going to go with the top one. So 3a plus 8b is equal to 31. If I substitute b for 2, this becomes 3a plus 8 times 2 is equal to 31, and since 8 times 2 is 16, we have 3a plus 16 is equal to 31. We can start solving this by removing the plus 16, and we can do this by subtracting 16 from both sides. And on the left, the plus 16 and the minus 16 cancel out to leave us with 3a, and on the right, 31 take away 16 gives us 15. To finish solving, we can now remove the times 3 from in front of the a, and we do this by dividing both sides by 3. And on the left, the times 3 and the divide by 3 cancel out to give us a, and on the right, 15 divided by 3 is 5. So a is equal to 5. And this means our final solution to problem 1 is a equals 5, b equals 2. In problem 2, we're solving 2d minus 4e equals 4 and 5d minus 3e equals 24. Now again, we'd like to eliminate one of the variables, and we need the same number in front of each pair in both equations, and we don't have that at the moment. So we could multiply the top equation by 5 and the bottom equation by 2, and this would give us a 10d in each of the equations. Or we can multiply the top equation by 3 and the bottom equation by 4, and this would give us a minus 12e in both equations. Either of these would be fine, but I'm going to go with the first option by multiplying the top equation by 5 and the bottom equation by 2. And if we start with the top equation, 2d multiplied by 5 is 10d, minus 4e multiplied by 5 is minus 20e, and 4 times 5 is 20. Moving on to the second equation, 5d multiplied by 2 is 10d, minus 3e multiplied by 2 is minus 6e, and 24 multiplied by 2 gives us 48. Now, since we're eliminating the d's here, and they have the same sign because they're both positive, we're going to do this by subtracting the bottom equation from the top one. So starting with the d's, 10d minus 10d is 0, so they're eliminated. Then moving on to the e's, we have minus 20e minus 6e. So minus 20e minus 6e. We notice in the middle that these two minuses are equivalent to a plus. So we're actually doing minus 20e plus 6e, and this gives us minus 14e. On the right, 20 minus 48 is minus 28. To solve this now, we can remove the times minus 14 from in front of the e, and we can do this by dividing by minus 14, and we can do the same on the right hand side. Now on the left, the times minus 14 and the divide by minus 14 cancel out to leave us with e, and on the right, minus 28 divided by minus 14 is 2, because dividing a negative by a negative gives us a positive result. So e is equal to 2. Now to find the value of d, we need to take this value of e and substitute it into one of the original two equations, and either one would be fine, but I'm going to go with the first one because the numbers are slightly smaller. So using 2d minus 4e equals 4, we can substitute e for 2, so this becomes 2d minus 4 times 2 is equal to 4, and since minus 4 times 2 is minus 8, we have 2d minus 8 is equal to 4. We can start solving this by removing the minus 8, and we can do this by adding 8 to the left and making sure we do the same on the right. And on the left, the minus 8 and the plus 8 cancel out to leave us with 2d, and on the right, 4 plus 8 gives us 12. Finally, we can remove the times 2 in front of the d by dividing by 2 and doing the same on the right. And on the left, the times 2 and the divide by 2 cancel out to give us d, and on the right, 12 divided by 2 is 6. So d is equal to 6. And this means that our final solution to problem 2 is d is equal to 6, e is equal to 2. In problem 3, we're solving 5x plus 2y equals 38 and 2x minus 3y equals 19. Now again, we'd like to eliminate one of the variables, which means that we need the same number in front of each pair in the two equations, and we don't have that at the moment. So we could multiply the first equation by 2 and the second equation by 5, and this would give us a 10x in both equations. Alternatively, we could multiply the top equation by 3 and the bottom equation by 2, and this would give us a 6y in the first equation and a minus 6y in the second, and then we could eliminate them by adding them. I'm going to go with the second option, which is multiplying the top equation by 3 and the bottom equation by 2, simply because it's a bit easier to add than subtract the two equations together. So multiplying the first equation by 3, we've got 5x times 3 is 15x, 2y times 3 is plus 6y, and 38 times 3 is 114. Moving on to the second equation, 2x times 2 is 4x, minus 3y times 2 is minus 6y, and 19 times 2 is 38. Now, since we're eliminating the y's, as mentioned earlier, their signs are different, which means we're going to add them together, because 6y added to minus 6y is 0, so the y's will be eliminated. So starting with the x's, 15x plus 4x is 19x. We know that 6y added to minus 6y is 0, and 114 plus 38 gives us 152. We can now find x by solving this equation, and we can remove the times 19 from in front of the x by dividing by 19 on the left and doing the same on the right. On the left, the times 19 and the divide by 19 cancel out to give us x, and on the right, 152 divided by 19 is 8. So x equals 8 is the first part of our solution. To now find the value of y, we can take this value of x and substitute it into one of the original two equations. Now I'm going to use the first one since it has a plus in it and they tend to be slightly easier to use. So 5x plus 2y equals 38 becomes 5 times 8 plus 2y is equal to 38. And since 5 times 8 is 40, we have 40 plus 2y is equal to 38. We can now start solving this by removing this 40 from the left, and we can do this by subtracting 40 from the left and doing the same on the right. On the left, the 40 and the minus 40 cancel out, so we're just left with 2y, and on the right, 38 minus 40 is minus 2. Finally, we can solve this by dividing by 2 to remove the times 2 in front of the y, and doing the same on the right. And on the left, the times 2 and the divide by 2 cancel out to leave us with y, and on the right, minus 2 divided by 2 is minus 1. So y is equal to minus 1. And this means that our final answer to problem 3 is x equals 8, y equals minus 1.